If a grammar is unambiguous, then it is useful for sentiment analysis of a language. If a grammar is converted into a Chomsky normal form or any other related normal form, then it is unambiguous. We will see how to convert a given grammar into a Chomsky normal form. For today's lecture, our objectives are to know useless symbols and unit and null productions, to remove useless symbols and unit and null productions from a given grammar, to convert a given grammar into Chomsky normal form. Chomsky normal form is defined as if all productions are of this form, either A tells to B or A tells to alpha, a single non-terminal, then we can say that a given grammar is in Chomsky normal form. Before converting a given grammar into Chomsky normal form, we have to convert it into a grammar which is having useless symbols, which is having no null productions, and which is having no unit productions. So these are the three preliminary simplifications. What is an useless symbol? The symbol which is not generating and not reachable, then it is treated as a useless symbol. So a useful symbol must be a generating symbol and it is a reachable symbol. If we could derive a string using the given symbol, then we can say that it is generating. And if from starting symbol we could reach to a given symbol, then we can say that it is a reachable symbol. Means we should reach from starting symbol to any intermediate sentential form using this symbol X, then it is a reachable symbol. How to remove a non-generating symbol? For example, given a grammar, first we have to identify a generating symbol. Here A is generating, but B is not generating any sentential form or any terminal symbol. So B is treated as a non-generating symbol. So we can remove the production S tells to AB. A non-reachable symbol is identified and we can eliminate the non-reachable symbol. Means there is no path from starting symbol S to that symbol. A is non-reachable variable or non-reachable symbol. The execution order is important. First we have to remove the non-generating symbols and then we have to remove non-reachable symbols. What will happen if we will reverse the orders? Still in the answer some useless symbols may be present. So the order is important. How to find a generating symbol? If there is a production A tells to alpha and every symbol of alpha is already known to be generating, then A is generating. Here we can remove S tells to AB because B is treated as non-generating symbol. Here S is surely reachable because it is a starting symbol. And all symbols in the body of production with S in the head are reachable. In the given symbol, S, A, B and terminal symbols small a, small b are all reachable. So we have seen how to remove useless symbols. Now we will see how to eliminate null productions. The null production is defined as if A tells to null is present and after iterative derivations A is reaching to null, then it is a nullable variable, and A tells to null is a null production. So we have to generate a language which is equivalent to the given language but without null productions. For example, here B tells to null is present but A tells to B is also present, so both A and B are nullable variables. How to remove null productions? A and B, two symbols, are nullable variables, so we have to add equivalent productions. Like here ASA is present, so we can add the equivalent productions. S tells to AS assuming that this A is null, S tells to SA assuming that this A is null, and S tells to S assuming that both A's are null. So like this we can add equivalent productions and remove the null production. Similarly, for B tells to null, we can remove this B and add S tells to A for maintaining the equivalence. Now we will see how to eliminate unit productions. A unit production is one of the form A tells to B, where both A and B are variables. So if after n iterations there is a unit production like this, A tells to B is there, B tells to W is there, then A tells to W is there in the grammar. So both A, W and B are all in unit pair, means they are unit productions. How to remove unit productions? First identify unit production, then if there exists a production B tells to alpha where alpha is a terminal, then for every unit production B tells to alpha, repeat the following step. Add production A tells to alpha to the grammar and eliminate A tells to B from the grammar. This is a production having a unit production A tells to C. So after adding a production A tells to A where C tells to A is present in the grammar, we can remove the unit production A tells to C, and the final grammar is without unit productions. Finally, we have to convert the grammar into Chomsky normal form. A Chomsky normal form is defined as where all productions are arranged in such a way that there are at least one terminal symbol or two non-terminal symbols at the RHS. So how we can achieve this? Arrange that all bodies of length 2 or more consist only of variables, and break bodies of length 3 or more into a cascade of productions, each with a body consisting of two variables. For example, every terminal alpha that appears in a body of length 2 or more create a new variable that has only one production. So S tells to ASA is a production present where three non-terminals are there. So we can break the three non-terminals and add some extra productions. S tells to AB, B tells to SA and A tells to XA. So at the right hand side we are having two non-terminals in every production, and here A tells to AA can be converted as having two non-terminals at RHS and one terminal at RHS.